Hi class, this is Dr. McGonigal with another lecture for your Intro to IO Psychology course. So today we're talking about research methods and we are continuing our conversation from video 1. So if you haven't already watched video 1, then you should stop this video and start with video 1. So in video 1 we went through the first 3 steps in the research process, and we're picking up today with step 4, which is collecting your data. So in this step, the first thing to consider is who would be some good potential participants in a study to test your hypothesis. And so this would depend on your research question and the method that you have chosen. And you want to consider what the implications of these participants are for your external validity of your study. So remember from our last video, we talked about internal validity and external validity. And specifically, external validity has to do with how much you think that your results of your study can generalize to other situations and other individuals beyond who were in your study. Our example hypothesis is that poor safety climate will positively relate to worker injuries on the job. And so who would be a good participant pool for this type of hypothesis, this poor safety climate positively relating to worker injuries on the job? Well, first we need to make sure that we are including workers, right? People who are working. What is another potential criteria? Well, they probably have to be working in jobs that have some hazard to them or some maybe potential for physical injury on the job. So those are 2 criteria that you would consider. And then other criteria that you might consider would include, like, are there any organizations around you that you think would be willing to let you conduct the study in their organization? Or do you have access to some other type of sample that you can get? So all of these questions relate to who your participants will be for your particular study. All right, so let's talk through some specific data collection methods. And note that this is different from the research design selection that we talked about in the last video. In this part of the lecture, we're talking about the actual methods that you're using to collect the data. So, for instance, you could use surveys, online surveys or paper pencil surveys. You could use interviews for people, particularly for qualitative type studies. You could use focus groups. Those are groups of individuals within an organization that are representative in some way. So you might have individuals that represent each department within the organization or different employee levels. And in a focus group, you would ask them a question and get their responses. Observational methods, and we talked about those in our last lecture, and archival sources. So let's talk in a little more detail about some of these. Survey methods, like I mentioned, could be paper and pencil or online. Some advantages of surveys are that they are inexpensive generally, they are quick and easy, and you can get large samples relatively quickly. So if you create an online survey using software, for instance, Qualtrics is a type of software that we use to conduct online surveys, you can send that to many people and get many responses very quickly. Some of the disadvantages include that it is more difficult to create a good survey than many people think. You have to consider things like reliability and validity of your measures, which we are going to talk about later in this lecture, and also the user experience of the survey, so making the survey as good as possible for the person who's taking the survey. Another disadvantage is that survey data may not be very rich. It could be sort of surface level. So for example, if I am surveying individuals about their perceptions of the safety climate within their organization, I am asking them very specific questions that they are answering, maybe on a scale of 1 to 5 for each question. But I cannot ask them follow-up questions based on their responses or probe deeper to get richer data like we can for things like interviews. Qualitative data sources include approaches that are interviews with employees, focus groups like I talked about earlier, and observational methods, which we talked about last time. An advantage of these is that they can provide rich data with a lot of detail about an individual and his or her experience. So you can go beyond what you get from survey responses. Disadvantage is that qualitative approaches are relatively time-consuming and difficult to collect data from large samples. So if you are conducting interviews with people, then you are going usually one by one, and you typically need many individuals to complete interviews in order to get a good enough sample size. So that can be very time-consuming. Archival sources are data sets or data sources that have already been collected through others and are made available for analysis. So these could come from the organization or through government-sponsored survey projects. One example of a data set like this is called the Health and Retirement Study. This is conducted by the University of Michigan, ISR, the Institute for Social Research, and it's a longitudinal study, meaning that every certain number of years, so I believe it's 4 years, they collect data from the same individuals about a number of things related to their health, their job status, their retirement if they are retired, things about their family, and they make this data available to researchers such as myself. So I have actually gone on their website and downloaded their data and used it to publish studies, and that would be considered an archival source. An advantage of this is that it can be pretty inexpensive for the researcher anyway, not for the institute. So what I just mentioned, the Health and Retirement Study at the ISR gets a lot of money from the government to conduct that study. So they apply for grants and they get funding from grants through the NIH. A disadvantage is that it's rarely collected with researchers' research questions in mind, and therefore it may not have all the variables that you need for your research project. So when I use the HRS dataset, as great as it is, for instance, it's representative of the U.S. population, and it has a lot of different variables in there. It may not have all of the variables that I'm looking for, and it may not have the specific measures that I want to use. So that would be a disadvantage. All right, so let's move on to talk about variables more specifically. So we're going to talk about how we measure variables. And the first thing to know about that is that we need to operationalize our variables. And what do we mean by that? Well, we have to measure them in some way, right? So let's take the example of safety climate that I've been using in the last lecture and this one as well. If we want to study safety climate, we have to have a way to measure it. So we might use questions in a survey about workers' perceptions of how much their organization values safety. And that's probably the most typical way to measure safety climate. So that would be an example of what I mean. Those actual survey questions are how you are operationalizing safety climate, your variable. So there are two main categories or types of variables. We have quantitative variables. Quantitative means numeric. And for example, these include age. So everyone has an age, and your age is a number. As your age goes up, numbers go up, so it's quantitative. The numbers have meaning there. Sales dollars is another example of a quantitative measure. Now, you also have something called a categorical variable, and this is a variable where you have different categories within that variable, and you could even assign numbers to those categories. However, those numbers don't have inherent meaning on their own. Let's use the example of managerial status. So if I wanted to collect information on a number of different people and ask whether they are a manager or not, then I would have a managerial status variable. And think about what that would look like. So if I had a spreadsheet open, I might type in participant 1, 2, 3, 4, 5, and so on. And then for each participant, I could assign a number. I could say 0 is not a manager and 1 is a manager. Now, I have to remember that that number that I have assigned to managerial status, it doesn't have numerical properties. So it doesn't mean that 1 is better than 0, or inherently on its own, it doesn't have a meaning until I assign it that meaning. So I assign it the meaning that 1 is manager and 0 is not manager. So that's an example of a categorical variable. Let's talk about different types of variables in research studies now. Independent or predictor variables are those that are manipulated by the researcher to observe an effect. This is typically referred to as an independent variable. Or they are not manipulated because they're not in an experimental design, but they are predicted to cause something else. So this is a predictor variable. Sometimes I use independent variable and predictor variable interchangeably when I'm talking about research studies. They are similar in terms that they are the thing that we're looking at to observe changes in something else. But if we manipulate it, it's the independent, and if we don't manipulate it, but we predict that it will cause something else or is related to something else, that's a predictor. The other category is dependent or outcome or criterion variables. And these are variables in which changes are observed. So if we have, for instance, a training variable, so we are doing an experimental study and training is our independent variable, we are manipulating training, and we want to observe the effects on job performance. Job performance would be our dependent variable, because our job performance would be said to be dependent on the manipulation of our independent variable, which is training. So if it's a non-experimental design, this would be considered a variable in which changes are observed as related to the predictor. So for example, we might say that the personality variable of conscientiousness positively predicts job performance. And so the variable of conscientiousness in that case would be our predictor, and job performance would be our outcome. One thing to keep in mind in terms of differentiating between the independent or the predictive variable and the outcome or the dependent variable is that the DV outcome criterion variable is what you are interested in explaining. For example, if we take the hypothesis that poor safety climate will positively relate to worker injuries on the job, what is the criterion or outcome variable there? If you said worker injuries on the job, you would be correct. Here are some examples of independent and dependent variables and predictor and criterion variables. So at the top we have safety training, our independent variable, manipulated, and we observe the effect on number of injuries. That would be our dependent variable. On the bottom we have a predictor of conscientiousness, and that would relate to our criterion or our outcome of job performance. All right, so let's check your knowledge, and this should look familiar because you did one of these in your last video. So take some time, pause the video if you need to reread this, and I will give you the answers in just a second. So the first question is, what is the independent variable? And so the independent variable here is the coaching program. So the researcher manipulates coaching in terms of assigning 25 people to get coaching and 25 to be the control and to not get coaching. So coaching is the independent variable. What is the dependent variable? Well, if you said work stress, then you would be correct. The dependent variable in this case is work stress. The researcher is observing the effects of the coaching program on the work stress levels. So the work stress levels are dependent on the coaching program. All right, so here's the second one. And again, you have seen the scenario, so if you need to pause, go ahead and do so. The first question is, what is the predictor variable? So you might have observed that this is a non-experimental design, so the researcher is not manipulating anything, the researcher is simply observing. So the predictor variable in this case would be the experience level of the servers. So you have experienced servers and you have inexperienced servers. And what is the outcome variable? So the outcome variable in this case would be customer service. So the researcher is wanting to know whether the outcome variable of customer service is sort of predicted by the experience level of the servers. So let's go back to our example. Our hypothesis is that poor safety climate will positively relate to worker injuries on the job. Think about this hypothetically. So if you were to actually study this, what would your predictor variable be and what would your outcome variable be? Feel free to pause the video if you want to take a minute to think about it. But the predictor variable would be safety climate. The outcome variable would be worker injuries on the job. Now think about how you can measure your predictor variable. I already mentioned earlier that safety climate is typically measured using surveys. And how about measuring your outcome variable, worker injuries on the job? There are different ways to do this. I'll just provide one example for you, which is that you could get archival data from the organization, and you could match that up with people's responses to their survey. All right, so now let's talk about the quality of measurement in research. And there are two main concepts to go over here. One is called reliability and one is called validity. Reliability refers to the dependability of a measure or its consistency in measurement. So in terms of reliability, one of the examples that I like to use is the example of a scale. If you weighed yourself now and then at the end of this class and you weighed the same both times, you would say that the scale is reliable because it has measured your weight consistently. If you measured yourself now and then at the end of listening to this video and your weight was different, then you might begin to suspect that the scale is not reliable. Because it's not likely that you've lost or gained weight just during the time that this video happened. So again, reliability is about consistency and stability. We can think about consistency in terms of time, raters, equivalent forms, and items. And we'll go through each of those in turn. Test-retest reliability is the first form of reliability that we'll talk about, and this is reliability over time. So to test, when you do test-retest reliability, you're assessing the stability of scores on a measure over time. So to get this, you measure the same individuals at 2 time points, kind of like we did with our example with the scale. But in IO psychology, we're not really considered with weight as much as we are with things that will affect workers and the workplace. So 2 examples of something that we might assess retest reliability for are personality and intelligence. So for both of these things, personality and intelligence, they tend to be fairly stable. So your personality can change slightly over time. Your intelligence can also change slightly over time. But it takes a long time for those things to change, and they generally don't change from minute to minute. So we would seek to determine retest reliability to make sure that scores are stable over time. In order to assess it, we look for a correlation between the 2 measurements, and particularly we look for a correlation that is around 0.7 or greater. If you've had any kind of statistics class, then you probably know that correlations range from 0 being the lowest possible correlation to positive or -1 being the highest possible correlation. So 0.7 is toward the higher end, and we seek to have that correlation be around 0.7 or higher. Here's an example of what it would look like to have high test-retest reliability. So you have participants in the left-hand column. You have their measure A at time 1. You have their measure A at time 2. So let's say their measure A is personality. scores. So scores on an extroversion test. At time 1, Sally had a 78. At time 2, she scored a 79. Those are very similar. Susan scored 62 at time 1 and 59 at time 2. Again, they're fairly similar. And we can go through each person and see that their scores are fairly similar from time 1 to time 2. And in fact, if we calculated a correlation of the numbers in the time 1 column with the numbers in the time 2 column, we would get a correlation value of 0.99, which is very high. Another type of reliability is called equivalent form or parallel form reliability. And this is to look for reliability between different types of measures or different forms of the measures of the same thing. So, for example, if I created 2 versions of an exam for this class, I might want to know, are these 2 versions equivalent in what they measure and how they assess student knowledge? Here's an example of very high parallel form reliability. So you'll notice here that, again, we have participants in the left-hand column, and we have 2 columns of scores, but the difference here is that you have measure A at time 1 and measure B at time 1. So it's the same, maybe the same time frame, but you're comparing measures. Whereas with test-retest reliability, you're looking at the times. The times are changing. So for equivalent or parallel form, the measures are changing and you're comparing those measures. So let's say each person took took the test at time 1 and test B at time 2, so test A at time 1, test B at time 1, and we calculated a correlation between those and attained a correlation of 0.94. That's very high equivalent or parallel form reliability. Internal consistency reliability is something that we are concerned with when we have multiple items that measure the same thing, and this is very common within IO psychology. So you've probably experienced the situation before where you're taking a survey and you're like, geez, I'm answering very similar questions kind of repeatedly, right? And you might be wondering why that is. Well, one of the reasons is we look for this internal consistency reliability. We want to make sure that the items that are measuring our particular construct or our variable are similar to each other, or that they're eliciting sort of similar responses. So we use this type of reliability when we have a measure that has quantitative properties, for instance, a Likert type scale ranging from 1 to 5. And again, we need multiple questions in the scale, and we look for a positive correlation among the different items of the same measure. Okay, so there are 2 ways that you can calculate internal consistency reliability. One is split half reliability, and this is when you correlate the total score on a random selection of half of the items with the total score on the other half of the items. This is less common. Then you have Cronbach's alpha statistic, which is very common in IO psychology. This is symbolized as the Greek letter alpha, and it's based on the average of the inter-item correlations and also the number of items. So the more items you have in your measure, the higher your Cronbach's alpha will generally be. So similar to before, we seek alpha levels that are at least 0.7. For the correlation, that's a fairly strong positive correlation. Here's an example of a measure of organizational commitment. So this is a measure that is fairly frequently used in IO psychology. An example question is, I would be very happy to spend the rest of my career with this organization, and this organization has a great deal of personal meaning to me. I feel a strong sense of belonging to my organization, and I feel emotionally attached to my organization. So take a second. Do you think that this measure would have high internal consistency reliability? Now, again, what that means is that people's scores on the items would be similar to each other. So if I tend to say, I agree that I would be happy to spend the rest of my career with this organization, I am also likely to say it has a great deal of meaning to me, I feel belonging to it, and I feel emotionally attached to it. Certainly there will be some fluctuations, but overall, if you're answering that you agree with some of these, you should be also answering that you somewhat agree or strongly agree with the other ones as well, right? So in fact, yes, this particular measure generally has a reliability around 0.8 or 0.85. Inter-rater reliability is used when you have two or more judges or raters who are observing behavior, making judgments, or coding responses to a survey. These are used to assess the extent to which raters agree on something. And many of you may have experienced this before. So if any of you have had an interview where you've had more than one person in your interview, then inter-rater reliability may have been a concern. So the idea is that if you have 2 or 3 or 4 people rating someone during a job interview, for example, you would hope that they would at least somewhat agree with each other in terms of how that candidate performed during the interview. If there are large discrepancies, then that means there's a low level of inter-rater reliability, and that that would cause considerations in terms of what to do in that case, right? Here's an example of very high inter-rater reliability. So you can see that there's a participant list on the left-hand side column. Then you have rater A and you have rater B providing ratings. So let's pretend that each of these people went through an interview, and rater A provided Jim with a 78, rater B a 79. Skipping down to Xavier, rater A provided Xavier with a 63, rater B a 54. In general, these are pretty similar to each other, so the correlation between rater A's ratings and rater B's ratings is 0.99, which is very high. Okay, so that sums up reliability. Next, we are going to talk about validity. And validity is the extent to which a measure is actually measuring what it is intended to measure. Now, I realized that in our last video we went over internal validity and external validity, and so it might be confusing to have different types of validity that you have to learn now. Now remember that internal and external validity have to do with your confidence in your experimental or your non-experimental methods in terms of the degree to which your outcome is due to the predictor or independent variable in your study, so that would be internal reliability, and the findings could generalize to other people or situations, which is external validity. So here we're kind of putting that aside for the moment, and we're talking about validity in terms of measurement. Okay, so there are 3 common ways to demonstrate validity. There's content validity, criterion-related validity, and construct validity. And we're going to talk about each of these. Content validity is answering the question, does the test or measure cover a representative sample of the construct being assessed? So let's take, for example, we are developing a test of college algebra. So we want to refer to algebra textbooks and consult with algebra instructors to develop questions for that test that cover the domain of college algebra. We want to make sure that the questions that we're asking are relevant to college level algebra and not deficient. So what do I mean by not deficient? Well, we don't want to kind of skip over anything really important that has to do with algebra. We want to include everything that is relevant and important to assessing college algebra. So the idea is to cover the whole area that you're trying to assess without being deficient. And there are no statistical tests to determine content validity, but subject matter experts can help determine it. In IO psychology, SME is a commonly used abbreviation, and this refers to subject matter experts. So, for example, if I wanted to develop a new test of personality, then I would want to consult with subject matter experts who are experts in the matter of personality to help me create my test to make sure that I have good content validity. I'm covering all domains of personality and I'm not deficient in any way. Criterion-related validity is the validity of a particular test predicting a outcome variable or a criterion variable that you care about. So typically, criterion-related validity uses a correlation or maybe a regression-based approach, and we'll cover those statistics a little bit later, to determine the degree of association between a measure and an outcome. So when you hear the term validity coefficient, we're referring to a correlation between a measure, like a predictor, and a criterion. Let me give you an example. So if we are asking whether the GRE is a valid predictor of future graduate school performance, then we are concerned with criterion-related validity. There is some debate, right, as to whether or not the GRE is a valid predictor of future graduate school performance. And one of the things that the Educational Testing Service, ETS, who creates the GRE, one of the things that they do is conduct studies. So they take people's GRE scores and then they find out how they've done in terms of future graduate school performance. And they correlate those to see, is the GRE able to relate to or predict people's future performance in graduate school. Construct validity refers to the accumulation of evidence that a measure is really measuring what it is intended to measure. So construct validity has to do with, again, so are we actually measuring what we say we are measuring? I may, for instance, want to develop a new test of personality, like I mentioned earlier. If I do that, how do I know that I'm really measuring personality and I'm not measuring something else like intelligence or, I don't know, some other variable? We need to know whether our measure is really measuring what we think it is measuring. Convergent validity is the degree to which a measure correlates with other measures with which it should have a relationship. So, is it correlating with measures as we expect it to? So with our example of coming up with a new measure of personality, we would want to take a look at how the subdomains of personality correlate with things that we know they should correlate with. So in IO psychology research, we know that conscientiousness, the personality variable of conscientiousness, strongly predicts job performance. So we could take a look at our relationship with job performance between our measure of conscientiousness and our measure of job performance, and if we're not seeing that, then that might bring our convergent validity into question. Discriminant validity is the degree to which a measure does not show a relationship to things it should not relate to. So, for example, intelligence should not correlate with eye color. So we know that, so we should not find that relationship. So it's all about finding correlations that you expect and not finding correlations that you do not expect. Those are some ways that we determine construct validity, or whether our measure is really measuring what we think it is. All right, so this slide here provides an overview of the different types. So we have content validity. Does our measure adequately sample a domain? Remember, are we covering the full domain of something and not leaving anything out, not being deficient? Criterion-related validity is seeing our relationship between our measure and an outcome. And construct validity is showing convergent validity and discriminant validity. So does our measure correlate with things we expect it to and not correlate with things that we don't expect it to? And one view of validity, and the one that's in your textbook, talks about all three of these as being subdimensions of overall construct validity. So the overall confidence that we have that our construct is valid, that it's measuring what it's supposed to, that it will predict what it's supposed to, and that it relates to other variables like it is supposed to. Okay, so one last thing that I want to mention before I conclude this video is just differentiating between reliability and validity. And I should say that these concepts are sometimes confusing for students and do take a while to sink in. So please feel free to ask me any questions that you have, and I would be happy to go over it again with you. So in terms of reliability, we talked about that as consistency, and we gave the example of a scale. So if the scale is measuring your weight the same at time 1 as time 2, then we would say, hey, that's a reliable scale. But what happens if the number is really off, right? So it's adding on 20 pounds. Nobody wants that, right? We don't want it to add on 20 pounds usually. So in that case, we have a reliable scale, right? Because it's giving us the same measurement at both time points, but it's not valid because it's inaccurate. It's not assessing it in the way that it should be. It's assessing something else, not weight. So that's an example of how we can sort of differentiate reliability and validity. So a scale can have great reliability, but not be valid for what you're using it for. Validity, on the other hand, has to do with the intended purpose of the scale. So is it a valid measure of personality? Is it a valid measure of intelligence? Is it a valid measure of performance? And we determine whether it is a valid measure of those things by assessing content, criterion-related, and construct validity evidence.